Hi, everybody. Welcome. I'd like to thank you for coming. I know it's been a long day here for presentations. I hope not to bore you to death. I think we did some interesting things at Vortex. I would like to start by thanking a bunch of people. I know I look like Two-Face right now because of my lighting. But thank you. I would also like to thank PPI and Vortex for giving me the opportunity this summer. So Vortex Global, who are they and what are they? Okay, well, Vortex is a, excuse me, is a dry bulk handling solution company. They create slide gates, diverter valves, and loading spouts for companies to move dry bulk product. Now, these are mostly custom designed to fit a company's needs. Now, Vortex solutions are used in a multitude of companies and industries. Industries like milling, mining, in food and beverage, and even pharmaceuticals. They work with over 20,000 companies, including PepsiCo, Nestle, Kraft Foods, P&G, and even Cargill, the grain elevators that you often see here in Kansas. Now, I want to show you this. This is at the main entrance to the main Vortex facility here. This wall here is showing many of the different products that are used over at Vortex. Or not used at Vortex, but instead have used a Vortex product in their manufacturing. Now, this is actually a demonstration video of what Vortex diverter valves are. I know it can be a little confusing just hearing the term diverter valve or dry bulk handling solution, but I'd like to show you this video here real quick. It might help shed some light on the subject. So this is a gravity view diverter that is created at Vortex. And so that kind of is what a diverter valve is that Vortex makes. And they make many other products as well. Again, custom designed for their company's needs. Now, the other main portion of this is Spectrum Metalcraft. Spectrum Metalcraft was a company purchased by Vortex roughly 2 years ago. It's once owned by a company named CASA. Internally, though, it's referred to as 304. The main facility is referred to as 1725. So if I accidentally slip up and say either 304 or 1725, that is what I'm referring to. So now Spectrum is a full service system. Serving industry of custom metal fabrication, again, similar to Vortex, but more customized, less of a singular product and instead making multiple products. Services include welding, assembly, and painting, which was one of the things that I focused on during my internship. So we'll move right along here. And so PPI focused areas. There's a lot of areas that we kind of focused on during this. These are the main 5 specifically. Either they had a process proposal for improvement or just to look at them to see if any process improvements could be made. And we'll first start off with electropulp. And sorry about that. I did add the summaries of what we had going on. Now, first things first is electropolishing. Electropolishing is a metal finishing process. Is the reverse of electroplating. As I'm sure you saw with Sophia's presentation from Duncan. And now what it is metals is placed within an acid bath. And it's an electrify, removing ion by ion of metal off the piece, giving it a nice shiny finish. In the top left, you can actually see a product that has not been electropolished yet versus the right. You can see the shiny, smooth finish that it's given. Now, in the bottom left, you'll actually see the acid bath. But once it's out of the acid bath, it's actually taken to a rinse bath instead, which you'll see to the right. right? And you can see the color of that. That is from the acid itself, as well as the chromium coming off the pieces in drag out. Now, so why was this process looked at? Most of the waste coming off the electropolish machine was in rinse water. Rinse water is mixed with the acid wash and particles and starts to deteriorate after somewhat time. Now, is mixed with acid as well as metallic particles containing chromium. Roughly 3,600 gallons of water are disposed of per year, but that is once I arrived. There's actually a process change before I arrived that helped dramatically decrease this as well. But it can be expensive to remove. Each gallon costs about $1.16 to remove from this facility through Safety Clean vacuum service, including the gallon cost as well as disposal per time costs. It roughly averages out to about $5,400 a year in disposal costs for the electropolishing system. Now, currently, there's no system to treat it at the Vortex main facility, and it cannot be dumped down the drain due to a high concentration of chromium, 11 milligrams per liter within the rinse water itself. So what were the solutions? Well, the first one was a transfer to Spectrum. Spectrum has their own wastewater treatment system, and rather than using the vacuum service, the main facility would transfer this wastewater over to the Spectrum facility, saving $5,400 in costs. But this also helps keep the water within the city itself rather than transferring it to a treatment facility in another city. Now, another solution looked at was increasing drip time. As I mentioned earlier, drag out. Drag out is what happens is the particles that stick to and slide off of the metal once it's removed from the rinse bath itself, metal and the acid from among them. Now, drag out can significantly decrease the lifespan of the rinse water. But by increasing the drip time over the acid bath, we can actually decrease the amount of drag out. In a study done, it was said that about 15 seconds over the acid bath would dramatically decrease the amount of drag out heading into rinse water. And so these were kind of the solutions for electropolishing. The next item on my list, though, here is machine coolant. Now, coolant is used in both machines at Vortex and Spectrum. This includes CNC routing, lathing, cutting, sawing, and laser machines. And coolant has many uses, the first thing being chip clearing, which you'll see at the bottom. Those are chips coming off the metal once it's cut. Now, chips, if they're around the cutting surface, can degrade the tool as well as disturb the piece itself. So coolant is helping to remove those chips from the surface area. Now, the second portion is lubrication. The cutting area between the surface of the metal and the cutting tool is extremely hot and can cause many problems if friction is not removed from that, such as flash welding, which welds the cutting tool to the piece itself, destroying both. Now, lubrication from coolant helps by removing that friction, able to make sure there's not as much heat coming off of it. And actually, the most surprising thing that I found for machine coolant is that cooling is actually the third most important part. Chip clearing and lubrication are much more needed during the coolant process, as cooling can actually cause a bunch of issues as well. While it is true it needs to help cool down the cutting tool, recent technologies have made it easier to do this just by higher speeds. Cooling can also cause what's called flash cooling, causing microfractions within the tool itself, decreasing its lifespan. Now, the type of coolant process used at Vortex is called flood coolant. This is where hoses are attached to near the cutting surface and then blast high amounts of coolant liquid at the cutting surface to remove as much friction and heat as possible, which we'll actually see here in the next slide. Here's a video down here to the bottom right. This is a high pressure coolant system. You'll see that there's a lot of coolant coming off the cutting surface. Here it is, as you can see. Now, this process is expensive. If machines hold vast amounts of coolant, machines can hold up to 330 gallons to 110 gallons at a time, and have to be replaced at an average of about 3 months. About 4,000 gallons were used in 2020, and an average of $1.16 per gallon was used to remove them, roughly about $4,700 in disposal costs. Now, while there's 4,000 gallons of coolant, this is not including the separation of concentrate and water, which is done at the facility itself. In fact, 1,900 gallons of coolant concentrate were purchased in 2020. They come in about 275-gallon totes and about $4,400 per tote, leading to a cost of around $31,000 for the purchasing of coolant. But there's other issues with coolant as well, as coolant can be hazardous, is considered an irritant to both human skin and eyes. And as you can see from the video, it goes everywhere within the machine, especially at high pressure systems. This means that it needs to be cleaned up before being used again. Now, what are some solutions? The first one was coolant recycling. There is systems out there that can treat and recover used coolant from machines. By using certain systems like this, there's savings up to 60% on coolant purchases, 90% on disposal costs. So now return on investment for this system would be within 2 years. There was issues brought up with this, as there is certain bacteria that can get into used coolant and degrade not only the cutting tool, but the pieces themselves. So another system that was brought forth was minimal quantity lubrication, or MQL. This would actually replace the coolant system entirely. Rather than coolant using massive amounts of liquid, MQL is different. MQL uses a fine mist lubricant that helps reduce the friction between the cutting surface and the metal more dramatically than coolant does. This means a reduced friction as well as reduced heat. In fact, most of the heat coming off of this MQL system actually comes off in the chips, which MQL uses air, compressed air, to help push the chips away from the cutting surface. This is a significant decrease in price as well as just amount of liquid needed. We're going from gallons to ounces used in a day, from MQL versus coolant. Now, return on investment with MQL would be less than a year. And the lubricant is actually burned off during the cutting process, so it does not pose hazards to human health or cleanup. And in fact, that raises the value of the chips for the recycling process, as they're not wet and dragged down by coolant, and saves over $20,000 a year in coolant costs. So that was machine coolant, and we now move on to vibratory tumbling. Once again, this is a metal finishing process. And so what happens is that metal is placed within what is called tumbling media. This can be made out of many different materials, most common being clay and ceramic. Anyway, the metal is vibrated and rotated within the tumbler media. The media acts as a file to this metal surface. And you can see here on this back end, I'll show you the video here now. But you'll see as it is rotated in, it is just tumbled. You'll also see there's water spouts in the back end. These waters absorb particulates coming from the metal as well as the used media, leaving a nice, smooth, and shiny finish. However, there is problems with this as well. Waste from the tumbler media comes from sludge and water. Now, the sludge is, as you can see here in these videos, is a combination of the metal filings, the tumbler media scrap, and water. And the water becomes more diluted the longer it is used. In fact, it starts maintaining about that color within about 7 hours of use, and is also, again, disposed of through a vacuum service and is expensive. Around 3,300 gallons are disposed annually. Again, roughly around 5,400 in disposal costs, as it needs to be disposed of much more frequently than electro polishing. However, this is not a hazardous waste stream. There's very few particulates from it shown in lab results. So solutions. Again, a transfer to Spectrum would be the most logical choice for disposal. This way, it nullifies the transfer from vacuum service and saves on disposal costs. However, another idea that was brought forth was the idea of using cascading bins. The current system uses a singular water holding bin. And however, cascading bins would allow the sludge to settle within the bins and prolong the life of the bin's water as it continually flows down clearer and clearer. This can save up to 1,650 gallons a year just by adding the system and prolonging the life of the bin's water. And this is powder paint. This was at the Spectrum facility painting service used is mostly powder paint. Paint is applied to the surface of the metal and has been baked on. Spectrum uses a multitude of colors depending on what a customer wants. Mostly is gray, black, white. However, there are certain colors such as candied purple or even bright orange that can be applied. And these, as you can see here on the bottom, this is a container that holds the powder paint and is then blasted through. I got some pictures of the inside of the painting booth. Now, powder paint is disposed of as a special waste. The powder is actually vacuumed out of the booth. The original process was it was vacuumed out of the booths and then placed within steel metal drums. These were stored until a certain number were full, roughly about 8. And then they were baked into a solid form. You can actually see the top bin is an unbaked steel barrel, while the bottom 2 images are of a baked barrel. There you go. Now, once these were done, they were then shipped off to the city landfill. Now, once they're solidified, they're not considered a hazardous waste stream. It is the powdered form that can make them hazardous. This creates about 1.1 tons of steel barrel waste per year, and it can be a lot. Now, solutions. There's an idea brought up, not by myself, but by one of the powder paint specialists over at Spectrum after visiting another facility, that instead of using steel barrels, the powder paint could be baked within the cardboard boxes themselves, removing the steel waste altogether. This saves about 1.1 tons of steel barrel waste per year and about 12 metric tons of carbon dioxide equivalent each year. Also saving about $1,200 per year disposal costs, which this system has actually been implemented already over at the Spectrum facility after all these ideas were found. And finally, stormwater. Over at Spectrum, they just purchased it, and there was a lot of external risks to stormwater, such as pallets, metals, and dumpsters. We are able to kind of help identify some of these potential stormwater risks and help to identify and get the necessary paperwork in order as well. And I can say that before I left, there was a lot of cleanup done as well. So, and that is my presentation. I felt like I went a little fast, but if anyone has any questions, I'll be more than happy to answer.